This lesson gets us back into graphing square root functions, or just graphing functions in general. So we're going to start off on this one with the square root function. And since this one is the parent function, we're going to graph it using a table of values. And then after that, we'll go back to just showing shifts of graphs. So we're going to have an input and an output table. And we're going to start by graphing the parent function of the square root of x. So I'm going to try some positives and some negatives. Let's start off with an input value of 0. So what is the square root of 0? The square root of 0 is 0. So I'm going to plot that point right here. And then I'm going to put in 1. What is the square root of 1? The square root of 1 is 1. So I'm going to go 1 in the input, 1 for the output. And typically the next number we try is 2. But I don't want to try square root 2. Why would I not want to try the square root 2? Because I'm going to get a decimal. So instead of trying 2, I'm going to skip ahead and try the next number that I think will be easy to graph. I'm going to try the number 4. Because I know that the square root of 4 is 2. So I'm going to have 4 for the input value and 2 for the output value. So 4 and the square root of 4. The next number I would try would be 9, because that's the next perfect square. The square root of 9 is 3. So let's think about what happens if I put negative 1. What's the square root of negative 1? Well, the square root of negative 1 is imaginary, and that's not going to be on our graph. So the parent function of the square root of x looks like this. That's called the square root graph. This is a function. We can write it in function notation because it passes the vertical line test. For every input, there's exactly one output. 1, the square root of 1. 4, the square root of 4. 9, the square root of 9. So this one's a function. When we talk about the domain, that's all the x values. And if you look, this graph really just starts when x is 0. Because anything smaller than 0 is going to give us an imaginary number. So the very smallest value we can have for x is 0. And then the biggest value we can have for x is infinity. This thing could keep going as long as I wanted to. So if we write this in interval notation, 0 is included, so I'm going to have bracket, and infinity always has a parenthesis. Another way we could say this is x is always greater than or equal to 0. Okay, let's think about our range. What's the smallest y value we had? The smallest y value was 0, and the biggest y value was infinity. So y is also greater than or equal to 0. So this is the parent function. Everything we do now is going to be based off of the parent function and some kind of shift. So let's go down and let's look at this first one. Let's graph the function f of x equals 2 square root x. So if you notice here, I'm still going to put values in for x, but in order to get the y value, I'm going to have to multiply times 2. So I'm going to think about this in terms of an input-output table. I'm still going to start with 0 for x. The square root of 0 is 0, and 0 times 2 is 0. So this graph is still going to start right here. What happens when I put in the next perfect square? The square root of 1 is 1, and 1 times 2 is 2. So my input is still 1, but this time my output has doubled. What if I put in 4 here? The square root of 4 is 2, and 2 times 2 is 4. So I'm going to go over 4, up 4. Now, this is different than the parent function. The parent function looked like this. Input 1, output 1. Input 4, output 2. Input 9, output 3. So this was the parent function. So what happened by putting a 2 here is every single one of these y values doubled because of this 2. So this thing actually stretched vertically. If I would take a point here and pull like this, I would have a new graph. So we would say that this stretches vertically. And let's think about the domain and the range. The domain, when we write in interval notation, always starts with the smallest and then the biggest. The smallest value we have for x is 0, and the biggest value we have for x goes to infinity. And since 0 works, it's a bracket, and infinities are always parentheses. The smallest y value that we have is 0, and the biggest y value we have is infinity. Okay, let's talk about what happens if I put a number here that is smaller than 1. So let's graph f of x equals 1/2 the square root x. So this time when we put values in for x, in order to get our y value, we're going to half the number. So let's think about first our parent function. Our parent function starts at 0, and it's input 1, output square root of 1. Input 4, output square root of 4, input 9, output square root of 9. So there's our parent function. It looks like this. But this time, the parent function is going to be halved for the output value. So this time, instead of 1, 1, it's going to be 1/2 of 1. Instead of 4, 2, it's going to be 4/2 of 2. Instead of 9, 3, it's going to be 9/2 of 3. So you can see how this thing, instead of being stretched, it's actually being compressed. So it's kind of squeezing in. So we would say that this one compresses vertically. And again, the domain and the range on these, this one's still going to stay the same. The smallest x value we have is 0. The biggest x value we have is infinity. And the range is also 0 to infinity. And this is a bracket. Okay, what happens then if instead of having a number here, I put a negative sign? So let's graph the function f of x equals negative square root x. Well, the parent function stays the same. 1, 1, 4, 2, 9, 3. So there's the parent function. But this time, in order to get our function, we're going to have the same input values, but to get our output value, we're going to make it negative. So instead of 1, 1, it's going to be 1, negative 1. Instead of 4, 2, it's going to be 4, negative 2. Instead of 9, 3, it's 9, negative 3. So you can see how the putting a negative here reflects over the x-axis. So let's think about our domain and our range. The smallest x value, so x moves left to right, the smallest x value is 0, and the biggest x value is infinity. But this time the range is going to change. What goes on the left side is always our smallest value. And notice our smallest y value is down here somewhere at negative infinity. But the biggest y value we can have stops here at 0. And I know this can be a little bit difficult, domain and range, but we're going to talk about it quite a bit. So putting a negative on the outside of the square root makes this thing reflect over the x-axis. Let's go down here in this blank spot on the note sheet, and you're welcome to print off your own note sheet if you want. And let's think about, so I'm going to do a blank spot here. Let's think about what would happen if I put that negative sign on the inside of the square root. This looks a little bit different. Our parent function was always 1, 1, 4, 2, 9, 3. So our parent function kind of looked like that. But this time, if I put in a 0, I have negative 0, and the square root of 0 is 0. So I still have this point right here. But what happens when I put 1 in for x? I have negative 1. And the square root of negative 1 is imaginary. So the very first value on my input-out table that I can have is actually negative 1. Because when you put a negative 1 in for x, you actually end up getting positive 1. So what happens by putting a negative here, I have to put negative numbers in for x to turn this whole thing into positive. So this one is going to flip around and look something like this. So by putting the negative on the inside of the radical, it's going to reflect over the y-axis. So let's think about the domain and the range for this one. The domain is the smallest x value. Well, the smallest x value is over here this time, negative infinity, and it goes all the way to 0. The range, still the smallest number is 0, and it goes to infinity. So that one looks just a little bit different. Let's go over here on the left. Let's do 2 others. Let's see what happens to the graph whenever I put a 1 at the end. So what typically happens when we add a 1 at the end of our function? Well, this either shifts it up or down. And since I have a plus 1, it's going to shift it up. Let's think about our parent function. Parent function is this. But this time it's the parent function, but add 1 to get the y value. So that's just going to take this thing and scoot every single number up 1 unit. So we would say this is shifted up 1 unit. So the domain is going to remain the same. It goes 0 to infinity. But the range is going to change this time. The smallest y value I have is 1, and then it goes to infinity. Okay, this time let's put the plus 1 inside the parenthesis, or inside the square root. What does it mean when you put the plus 1 inside the parenthesis? Well, that's a left-right shift. Because now this time, in order to get the 0 value right here, I would have to put a negative 1 in for x. So what would make this whole thing 0 is if x was negative 1. So it's going to shift this entire graph over 1 unit to the left. So what's going to be affected here is the domain. This time the smallest x value we have is negative 1, but the y value actually remains the same.